Hello and welcome to this new installment of Built-in Public Chess Programming. In this episode we are going to render the board on the pieces using a presenter interface. The presenter serves as the bridge between the underlying game logic and the graphical user interface. It is responsible for transforming the abstract data structures such as the board state and the position of the pieces into a visually appealing display. As well, we are going to provide an interface to represent the player. In this case, I'm going to program a player that plays chess, picking pieces and moving it randomly. And finally, I'm going to create a game class to coordinate all these elements together. So I'm going to start creating a presenter interface. I'm going to create an abstract class with abstract methods and use it as an interface because Crystal doesn't have any interface keyword. So this is going to make the work. I'm going to define an abstract method called draw that I'm going to pass a board, and I'm going to create a directory called presenters with all the implementation of particular presenters. Okay, let's create now a CLI presenter that is going to draw the board and the pieces in the console. We are going to implement the draw method. That is going to return a string, and this method is going to draw the board. Okay, there is an error here. We have to put it in the chess.cr file, the dependency. Okay, we require the presenter, and the presenter requires all the particular implementation, so it's going to work in that way. Okay, we are going to create an spec file for the CLI presenter. So let me put here all the boilerplate needed for the spec, the require of the spec helper, and the describe of the class. That is going to be CLI presenter. And we have only one method called draw, so we are going to group it into another describe here. And we are going to have two specs. It should draw an empty board, and it should, well, we are going to put it as a pending first, and it should draw a new game. So we are going to test it in order to check that the specs are working, the pending specs, so we can start with the implementation. So we are going to put here the subject under test, and that is going to be the CLI presenter instance. And here we are going to create an empty board. And we are going to get that representation using the presenter. Presenter draw the new board. And this representation should equal to an empty board draw as a ASCII string. So we are going to put here a constant empty board. Okay, let me copy here. Let me copy an empty board. And this is going to be the ASCII representation of a chessboard. All of the squares and the row numbers and the column letters. Okay, let's start with the representation. I'm going to use a string builder that is going to be more performant than concatenating strings. So this is going to be the return, the string itself. So let's start looping over all the squares of the board. The first loop is going to be the rows. We are going to keep the row index, and the next loop is going to be the columns. We're going to keep the column number as well. Okay, at this point we are going to print out the first row of the board. Let me put it here. And we are going to print first the number columns. So the number columns should be the row index +1 if we are in the column 0. Okay, at this point we could use the case control structure over the piece variable in order to check if the piece contains something or nil. In the else case, we are going to control the nil case. That means an empty square. And in the case, in the other case, we are going to check for a pawn, a knight, what else? A rook, a bishop, and the queen and the king, in order to print out the symbol of each of these pieces. Okay, what else? We are going to represent here the bottom part of the chessboard. Let me copy it. Okay, we have to put some spaces here. I think that's right. Okay, and here for the letters. Okay, I think that it's everything is on its place. No, let me check. We have here the ending vertical bar of the last column. If the call index is 7, that is the last one. Let's check it, and there is an error because the numbers are too close to the first vertical pipe. We have to put it a space in there. Okay, let me check here. We are going to put a space here and run the tests again, and okay, now it's working. Okay, we can continue with the next spec that should draw a new game board. So let me copy the first test, and instead of well, we are going to set up a new game with the given board, and we are going to change this to a new game. So we are going to create the constant here as before. I'm going to use emojis to represent the different pieces. My terminal is not working very well with that kind of emojis because the black pawn is represented well, but the other ones are a bit shitty. So here we could select the different class of the pieces. This is kind of pattern matching, and we are going to draw here the different emojis for the different kind of pieces. In this case, we are going to copy here the black pawn. We are going to leave 2 spaces, and this is in the case of the black pawn, but if it's white, we have to copy the white version of the emoji pawn. Let me copy here. And okay, the same for the... We are going to put it in the same order as in the new game. So we are going for the rook. Let me copy here the black rook. And then the white one. Okay, again with the knight. We copy the emoji for the knight, for the black one. Okay, oh. And the white one. Okay, same for the bishop. Okay, this is the black bishop. And the white one. And now it's turn for the queen, sorry. The same, we are going to copy the black queen and the white queen. And the last one, the king. So let me remove this and copy the black king and the white king here. Okay, that's it. Let's check if it's working. And it's failing. It's failing because there are too many spaces in the rows of the pieces. Let me check. Okay, one space here. This is a bit annoying because okay, two spaces in the right. Okay, this is something common when your terminal or your application doesn't render correctly the 2-byte characters, in this case the emojis. But it's easy to fix. Let me put a space here, and if we try it again, okay, everything is working. Okay, now I'm going to create a main file in order to put all of this logic in there, instead of putting it in the chess.cr file, because this is going to affect to the tests. So it's better to put it in a different file. We are going to create a new board. We are going to create a new presenter object here. And we are going to set up a new game for the board. And pass it to the presenter to draw it. So now if we run this specific file instead of running the tests, we are going to get our game in the console. So now it's turn for the player class. We are going to do the same as the presenter class. We are going to create an abstract class that represents the interface of a player. In this case, we are going to have an abstract method called play that we are going to pass the port and the available pieces for this specific player. And the different instances of the player class are going to implement different strategies for the game. This is going to return a tuple of the piece that is going to move and the position, the target position. And the same, we are going to create a players directory in order to implement different kinds of strategies or players. We are going to add it here as a requirement. And now we are ready to implement our first player, that it's going to be the random player. The random player is going to get a list of available pieces to play. It's going to loop over the available pieces, select one of them, pick one of the movements that it's available for that piece, and loop over the pieces until we reach one valid movement. So in the constructor we are going to pick the color of the player, and we are going to implement the play method itself. Okay, this is going to return a tuple of piece and position, and we are going to shuffle the given pieces, and we are going to loop over each of the pieces. For each of the pieces we are going to get the possible movements of this piece, and if the piece movement is not empty, we are going to return. We are going to get a random movement over the possible movements and return the tuple piece and movement. Okay. For this class I'm not going to provide tests. Crystal doesn't have a proper mocking library needed to test these kind of things, and make test doubles and fakes is going to complicate too much the thing, so sorry, no tests for this part. Now we are going to create a game class that is going to orchestrate all the presenters, players, boards, and these kind of things. So I'm going to create the class. I'm going to require the dependency here, and we are going to start putting here a getter for the players, one for the white player and the other one for the black player. I'm going to put here a getter for the turn, and we are going to define private getters for the board and for the presenter. Okay, I'm going to create here the constructor, the initializer, and we are going to pass a presenter and the two players here, the white and the black. We are going to create here the board and initialize the game board. And we are going to create a new method here, a start method, that is going to start the play itself. We are going to define a game loop here until we finish. We are going to print the board. We are going to move pieces, each of the players. A player makes a movement, and we are going to toggle the turn. And what else? We are going to check if the game is finished. This is going to be our basic structure of the game. We can start printing the board using the presenter as we did before. And now we are going to move the pieces. Each of the players, depending on the turn, is going to move its own pieces. So player white in this case is going to play. We are going to pass the board and playable pieces of white color. This is something that we have to implement. and when it's turn of the black player, the same, but with blacks. Okay, now we are going to implement the private method in order to get the playable pieces of each of the colors. We are going to pass here a color, and this is going to return an array of pieces. So this method is going to return not capture pieces of the given color. That means playable pieces for me. And in order to do that, we have to store the references of the pieces just after the creation of the new board. So we are going to define here our private method, store pieces references. And we are going to loop over each of the square of the board, and we are going to store. Okay, this is going to be call, and we are going to get the element in that row and call in that specific position if a piece is not nil. We are going to get it, piece not nil exclamation mark, and we are going to get the color. If the piece is white, we are going to store that in the whites array, and if it's black, we are going to store it in the blacks array. Okay, we are going to create a private getter for that whites. That is going to be an array of piece, and we are going to initialize to an empty array of piece, and we are going to do the same for the blacks. So what else? Now we can filter those pieces for that are not captured. We have to define a capture method in the piece class in order to check if one piece is captured or not. Here in the piece class we are going to open the spec as well, because we are going to provide a test for that specific method. Here in the piece class we are using position -1, as a default. We are going to take that to describe if a piece is captured or not. That means that one piece should return 2 when the piece is captured. That means that its position is -1, and should return false if the piece is in play. So now we are going to run the tests in order to get the new ones. Okay, there are, and we are going to implement the tests itself. So one piece should return true if it's captured. We are going to create a random piece. We are going to set the position to -1, and we are going to call to captured method, and it should be true. Okay, this is failing because we have to implement the method. So here, for example, we are going to implement the captured method. Is going to return a boolean, and if the position is -1, should mean that it's captured. If we run the tests, the first one is passing, one is pending, so everything is working. We are going to implement the last one. Okay, let me copy here that we are going to change to it, do, and if it's in the position, for example, 3, 5, captured should be false. Let's run the tests, and they are working, so we can go back to the pliable pieces method. We are going to check if the given color is white, and if it's white we are going to select in the whites array those who are not captured. I have to put an X here, and the same for the blacks. I think that everything is okay. We are not providing tests for the game class, so we are going to check it using the main file. Instead of putting the presenter and board and all the stuff here, we are going to use the game class in order to orchestrate all that things. So we are going to put here the presenter, the white player, and the black player, and we are going to remove all of these, and we are going to instantiate we are going to call the start method of the game, and here we have to put a print in order to print out things. And if we run the main file, we are going to get an error. Okay, let me check. Color white. This is because we have to put it here the full namespace chess, color white and color black. And here there is another error, blacks. Okay, let me check. This is because we have to append a piece instead of the array itself. And finished is not declared, so I'm going to create a variable here, finished false. As well, I'm going to create here a turn count, and here I'm going to break the execution when at the third count of the play until we implement a real finish check. So if turn count is equal to 3, we are going to toggle that finish to true. Okay, another error. Possible moves. I did a mistake in the random player class. This is random moves. Okay, we are going to run another error. Okay, this is something catched by the compiler. We are returning tuple or nil here. This is because we could reach a scenario with we can loop over all the pieces and none of them give a valid movement. So I'm going to put here an exception, and we deal with that in the future. Okay, another error. Okay, I forgot how to type exception. Okay, and that's it. Okay, seems that there is an error here because nothing is moving. So let me check. Okay, I forgot to return here the piece on the target and make the movement itself. We have to move that piece to that target. So we are going to print the movement here as a reference. That piece moves to that target. Okay, let's run the main file now. Seems that there is an error because the original position of the piece is not erased. The movement is done, but the original position is not set to nil. So let me open the spec file of the board. We are going to create a new test in order to reproduce the bug. It should set to nil the initial position of a piece after the move. So we are going to create a random piece here. And we are going to store the original position, for example 3-5. We are going to reset the board. We are going to move the piece to the original position. Then we are going to set another position. Let's call it new position to 5, for example. And we are going to move the piece to that other position. And we are going to check that the original position should be nil, and the new position should not be nil. So let me run these tests. And there is an error. Okay, we could reproduce the bug. So we have to modify the move method of the board in order to get rid of that bug. We are going to store the original position of the piece before change it. What else? We are going to place it into the target position, and we are going to set the original position to nil or as empty. So we are going to check the original position. If it's not the default position, that means that the piece is captured. We have to check also that the target piece, set the target piece as captured. That means that the position should be -1, -1. If it's not captured, we are going to get the original position, row and call, and we are going to set that to nil. Okay, what else? We are going to implement the captured. We are going to get the target. If the target is nil, if the target is not nil, we are going to get the target and we are going to set the position to -1, -1. That means that this movement makes a capture, and we are going to set the target piece to captured. So if we run the tests, now it's working. So if we run the main again, everything is working. So let me return to the game. And now we are going to implement the finish detector. We are going to create a new class for that, finish detector. We are going to remove that, and we are going to delegate to the finish detector method to the finish detector class to update the finished variable. So we are going to create the finish detector class, and we are going to create as well the finish detector spec file. We are going to create the boilerplate for the spec, describe chess finish detector. Okay, let me copy here the specs, and let's go back to the class to implement the class itself. Class chess finish detector. We are going to create a method called finish, question mark, that is going to return a boolean, and we are going to check that the specs are working. So let me run the tests. There is an error. Okay, this is because I have to put here the requirement finish detector. Let's run again the tests. Pen thing, I forgot how to write. Okay, let me correct this, and now are working the specs. Those are the pending specs, and we could start to implementing. We are going to have two conditions to finish: when the king is captured and when the player demands yield the game. So we are going to create two different methods for that. King captured. This has to be public instead of private. This is going to return a boolean, and player demands yield. Let me correct here this typo. Demands. Okay, we're gonna start with the specs. We are going to implement the first one, should finish when the white king is captured. Okay, let me create the subject under test here, finish detector new, that will be the instance of the class. And to implement that test, we are going to pass the playable pieces, white pieces, to the finish detector. We are going to pass as well the black pieces. And we are going to check that the king captured question mark should be true. And as well, we are going to provide the winner method in order to get who is the winner. Should be equal to chess color black, and the reason. That is going to be a string equal to a white king captured. Okay, let me provide here the two newer methods, winner and reason. And we have to implement a factory method to get a list of white pieces without the king, and get a list of black pieces with the king, sorry. So we are going to implement in the piece factory class, we are going to implement a new method called random list that is going to return an array of pieces. and is going to take as an argument first an integer with the number of items in the list, a color of the pieces of the list, and one skip argument that is going to be a class, a piece class or nil, by default nil, that is going to be used to skip pieces of that list. So we are going to define an array of piece. We are going to return that array, while the return size is less than count. We are going to get a new piece, a new random piece of the given color, and we are going to set that piece position to a random value between 0 and 7 for the column, for the row. And if the skip argument is defined, well, if it's not defined, we are going to append that piece to the return array, and if the skip is defined, we are going to check if the class of that piece is different of the skip, and in that case we are going to append to that array. Okay, seems that it's everything in their place. So we are going to create a white list. We are going to pick 5 pieces, for example, of color white without the king. And we are going to the same. We are going to create a list of black pieces. In that case, we don't want to skip anything. And we are going to append manually the black king to that list. It could happen that we had 2 or more kings in that list, but we don't care. So let's go back to the finish detector class, and we are going to write the properties to pass the playable pieces. Playable pieces white is going to be an array. By default is going to be an empty array, and the same for black. And we are going to start with the king captured method. We are going to check if there is any king in the playable pieces for the white and for the blacks. And in case of we detect a white captured king, we are going to set the winner as color white, as color black, and the reason we are going to put white king captured, and we are going to copy this for the black one. We are going to set the winner as the white and black king captured, and we are going to return white king captured or black king captured. So we are going to run the tests, and there is an error, and this is because we have these 2 methods here that are returning nil. We are going to set getters for a couple of getters for the winner and for the reason. This is going to return a string, by default an empty string. Okay, we are going to provide a reset method here that is going to return a nil, and the winner is going to be nil once resetted, and the reason is going to be empty string, and we are going to set also the playable pieces as an empty arrays. Let me remove this. Okay, and okay, before run the test, we are going to put here the subject reset, and if we run the tests, okay, there is an error because this nil has to be uppercased. And we run the test again, and now it's working. Okay, we can continue with the next one. Should finish when black king is captured. We are going to copy the same test, and we are going to modify things in order to capture the black king. So we are going to put a king in the whites, and we are going to change here this and this one, and everything is working. Okay, and the last one should finish when both kings are present. Should not finish when both kings are present. So we are going to modify this. We are going to put a black king as well in the blacks. And the winner should be nil, and the reason should be blank. Okay, there is an error because I forgot to change this assert here. This should be false. And again it's failing, but it's another error. It's giving white as a winner, so that means that this is wrong. We have to put it in a separate conditionals. Okay, let's try again, and now it's working. Okay, let's go with the yield, game yield. Should finish when the white player yields. So first of all, we are going to reset the finish detector, and we are going to inject the white player into the detector. We are going to inject the black player as well, and we are going to check if any of the players demands a yield of the game. So what is a yield? I checked a lot of rules, but I decided to implement a yield when a player makes more than 40 movements without capturing any piece. This automatically is going to be considered a yield. So in order to do that, we have to add some methods to the random player and the player interface as well. So let's start with the player. We are going to add a new abstract method called yield ? that will give us a true when the player yields. I'm going to create as well this instance property here to count the movements without capture, and we are going to check if a movement is a capture here. If it's not a capture, we are going to increment the counter by 1, and if it's a capture, we are going to set it to 0. Okay, and we are going to implement the yield question mark method here. And if this instance variable placed since last capture is greater or equal than 14, we are going to automatically yield. We are going to pass here in the test, we are going to set the player weight, and for this test we are going to create a fake class. And for the black player, we are going to set up a random player. So the fake player class, what is this? This is a class that is going to behave like a random class, but we are going to set the internal counter to the given number. In order to do this, we are going to overload or override the constructor method, and we are going to pass the color as in the random player class, and this counter plays since last capture should be an integer, and we are going to set that variable. Okay, yeah, that's it. Okay, we are going to call the player demands yield method, and this should return true because the white player demands a yield, and the winner should be black, and the reason white yields. Okay, we can remove this and we can go to implement the demand yields. First of all, we are going to set the properties to set the different players, white and black. We are going to reset those properties here. And we're going to start to implement this function here. We are going to copy the same as in the king captured method, and we are going to modify it. White yield and black yield, and we are going to call a player yield, player white yield, and player black yield, and we are going to check if the white yields, and we are going to set the message, and the same with the black yield, and this conditional here, and yield. Okay. Okay, we can check now the tests, and something is wrong because I put yields instead of yield, and Okay, we have to put here not nil in order to get the real value instead of a nil. Yeah, now it's working. So we can move to the next one, that it's the same test as before but with the black player. So we can copy it and modify. We are going to put the black player as a fake player and the white one as a random one. We are going to modify this and run the tests, and they are working, so we can move to the last one. It should not finish when no player demands draw. So we are going to copy it. We are going to put random players, both of the players. This should be false, this should be nil, and this should be blank. And if we run the tests, everything is working. Okay, let's go now to the game class. So we are going to we are going to implement all the finish detector things here. First of all, we are going to pass the context to the finish detector instance. We are going to pass the playable piece white. The same for the black. We also inject the players, the player white and the player black. And I think that I'm going to move all this code to a private method. So I'm going to call it setup finish detector, and I'm going to move all of this into a new private method, setup finish detector. This will receive an instance of finish detector. Okay, and what else? We are going to implement the toggle here, another private method called toggle turn. That is going to check what turn is active right now. If it's white, we are going to return black. If it's black, we are going to return white. Okay, and we are going to update the turn variable with a new turn. Okay, this is not needed, and we are going to print here the turn. And this part here, I'm going to put it in an internal method as well, called message. I'm going to check if the target is a capture or not, in order to improve a bit on the message. And we are going to return the message itself. Okay, and I think that's all. We are going to run the main file. And there is an error, setup finish detector. This is because I forgot to pass the finish detector instance. And here there is another typo. Okay, let's run the main file again. And yeah, it worked. 209 turns. Okay, let me check that everything is working. Pieces are moving as expected. Yeah, it seems okay. Okay, we are going to put here who was the winner, since it's something that we had in the finish detector. Winner is finish detector dot winner, and we're going to put the reason as well. And let's run it again. To 123 moves, 186, 66, 76. It seems that it's working. Okay, let me check that the yields part is working. Black yields, white yields, white yields, white yields, black yields. Okay, seems that it's working. Okay, let's check how many time takes. About 1 second. So 1 second, taking into account that we are compiling the code and running it in a development mode. So if we compile the code, the code in a release mode, we are going to a full game. Maybe it takes 10 milliseconds or so. Not bad. So that's it for today's episode. In the next one, we are going to implement a new player with a more advanced strategy. So see you in the next episode. Bye.